So, this is a part of the lecture value engineering methodology. So, next phase is creative phase. So, in creative phase, various ideas are developed for the alternative ways to perform each function that is selected for the study. So, in the function phase, we actually select the function that is the low value function. That is a technique known as, we will do that in the next lecture, numerical evaluation. In that we get value improvement potential for the specific function. How we will do that, we will see. So, this was just diagrammatic representation of my functions identifying the basic functions. To identify the low value functions is one that is done using this numerical evaluation technique. When we have identified the low value functions, we develop the alternative ideas using creativity techniques. So, there are generally two approaches in problem solving, analytical and creative. Analytical approach is the general cost reduction technique. In analytical approach, the problem is stated, a direct step by step approach to the solution is taken. So, in creative technique, what happens, we work on the function and not on the part or product here. So, there are various methods of creativity: brainstorming, Gordon technique, checklist, morphological analysis, attribute listing are a few of them. So, in creativity, we use creative thinking, no rules, no limits, no rules, no limits to ideas, no criticism of the ideas. This happens in brainstorming. So, we do not let the regulations or other people control our thinking, and the thing is that if you do not look for the second answer, if you do not look for that, you will not find that. So, it is better to think out of the scope, out of the available scope or the perceived scope you have. So, what happens in brainstorming, criticism is ruled out, freewheeling is welcome. It is actually the group of 4 to 6 people at least who are launched around a table, and they perceptuously create thoughts intending to tackle a particular issue. So, the combination and improvement are sought here. Next is Gordon technique. In Gordon technique, there is one team leader who announces the broader function. The broad, okay, like he say, tell me something to make marks. People can say, okay, to make marks use pen, use pencil, this is one thing, okay, using product. Okay, so you can say to where to make marks is not defined yet. Okay, to make marks on a ground, use a stone. Okay, to make marks on a mud, use your finger. These are all creative techniques, creative ideas that are coming out. So, these are not kind of the factual or product oriented ideas, but these are not at all ruled out. No criticism is practiced in, no criticism is allowed in this creative phase. Okay. So, in Gordon technique, the broad idea is listed, broad idea is said, and the team start working on, and in between he will take a break and make the notes of the ideas which are being given, and if the team is getting out of track, he will again try to bring the team into the track and they'll work on the objective which they are to improve. So next is checklisting. In this strategy, agendas are planned to tackle a particular issue, that is they help our flawed memory, the memory in our back brain. Checklisting questions are put here. Like I said, the questions which I put in the starting slides here. What is the product? What is the cost of the product? What does the product do? What else will do this job? What else is very important here? So whatever else is there, what does that cost? This else, the other idea. In this way the list is made. So creativity or creative phase in itself is a big topic. We can talk about each technique at a stretch, but I am just trying to give an overview of what techniques are. There are other techniques as well, like Delphi method is there. Then we have morphological analysis. In this, what we do, we list the factors responsible for the product, For example, if I need to manufacture a pen, okay, I'll list the material is one factor, then color is another factor, color of the ink, then color of body is another factor. Then let me say I have chosen this material, one is plastic, the outer body, one is metallic and one is wooden, okay, or simply we put wood here. Color of the ink is red, blue, black, green, purple, golden and so on. Color of the body, let me say simply black, silver, golden, white or some textured. So what does morphological analysis say? It makes a kind of a factorial design. What is factorial design? We are having three levels of material, three kinds of material. We are having 1, 2, 3, 4, 5, 6, 6 levels of ink, and we are having 5 levels of my body. Each of the material is combined with each of the other factors here. Plastic body, red color ink, black color body. Plastic body, red color ink, silver color body. In this case, we will have 3 into 6 into 5, 90 alternatives. Okay, this is morphological analysis. Each of the alternatives here is selected. But in case of manufacturing, when we do, there are certain other techniques like response, surface methodology, and other Taguchi methods, etc. are there, which reduce these numbers. Those are actually the number of experiments which are to be carried out. So in this case, we will do the full factorial, all the factors would be worked on here. Next is attribute listing. In attribute listing, the first step is to list all the various characteristics of the product which is under study. The second step is to change or alter these attributes. By methods of this system, it is conceivable to unite new mixes of qualities or traits that will satisfy some current needs betterly. So next is evaluation phase. Evaluation phase selects and refines the best ideas to develop into specific value improvement recommendations. So what we do, we define the performance measures, we define the performance measures, then we rank the measures here, then we evaluate the alternatives. So, for instance, if I have chosen this morphological analysis, I have chosen these alternatives here. So, these all alternatives would be then evaluated. Plastic pen with red color ink and with black color body. So, what would be the cost? What would be the performance? What would be the acceptance by the customer? So, we can define the performance measure here as what is the cost. Okay. Second is durability. For instance, if I have selected plastic, metallic and wood body, the durability would be different. Okay. Then what is the appearance if I select that as one of the measure. So, these are all based on the customer requirements. How would the customer react? Then market acceptance. Acceptance or market response, better to put here. This can be put if we have once made the prototype and just tested in the market, test market has been carried out. So, what we do here, we eliminate the low potential ideas, that is we mark the ideas as acceptable, okay, not acceptable, and acceptable with some change, if there is some minor change, little change. So, all the ideas are put into one of the categories. The idea acceptable, or is the idea preliminary not acceptable, or is the idea acceptable with some change. So, eliminate low potential ideas here. So, these ideas acceptable appears to be feasible and have a relatively high probability of success. So, the low potential ideas are which are not acceptable. So, that is the ideas will have little or no potential at this time. So, this acceptable with a little change, that is kind of a maybe this be selected or maybe not. These ideas have potential, but they appear to need additional refinement or work before they can become the final proposals. So, then ideas are grouped together. The similar ideas or the remaining ideas which are selected, the high potential ideas only, high potential ideas, they are grouped according to the similarity. So, the categories are examined and they are examined to determine if they should be modified or combined with some other ideas, those things happen. Then we select the appropriate idea. Selecting appropriate idea is we select the highest potential idea based on this criteria selected. These are the idea criteria or measures. We select the appropriate idea finally. This is a champion idea who will serve the purpose in a better way. So, we also list the advantages and disadvantages of each idea and keep the record, that so as if this idea doesn't work, doesn't go well in the implementation phase, we can select some other idea from the reserve here. So, the next phase is development phase. So, in the development phase, we determine the best alternatives that is made ready for presentation, the alternatives for presentation to the decision maker. So, we conduct a life cycle cost analysis. Life cycle cost is purchasing cost plus operations cost, or I would say operating cost, plus disposal or replacement cost. Cost like when you purchase your motorbike, the purchasing cost is rupees 40,000, and operating cost is you spend rupees 2,000 per month on the fuel. Replacement cost is when you sell your motorbike after 5 years, when you want to change that bike, you will sell it at maybe 15,000 rupees. So actually this is minus here. I'll correct myself here. Purchasing cost is 40k here. Let me say in 5 years you spent 2,000 per month is 24,000 per year. 24 into 5 is about 120. 120k on fuel minus you sell it at 15k. This is your life cycle cost. In general, the normal cost is just the purchasing cost, or that is the price of the product. But it is recommended to conduct a life cycle analysis to see what is the life cycle cost, what will be the replacement cost, what will be the disposal cost of this product. Okay. So in this operating cost, maybe new tools, repair cost is also there. We need to get the bike repaired, preventive maintenance, corrective maintenance, all those things comes into play here. The new tools or fixtures, additional materials, new assembly instructions in manufacturing, all those things come into this life cycle costing. Next, we determine the most beneficial alternatives. In evaluating the alternative, the value engineering team should consult personnel who have knowledge about the item function. We consult the expert here. Okay, expert who has the knowledge about the product function, the operational constraints, expert who is having knowledge on functions, the operational restrictions, dependability and requirements, and so on. So this person will tell us what is the life cycle benefit, or do the benefits outweigh the cost, what are risks. Then we develop the implementation plans to implement it in the next phase. The implementation plan for each alternative should include a schedule of the requirement implementation steps, that when and where the specific step has to be conducted. Identify when would this conducted, again the out of 6 serving men we will use this. When, who would do this, who would do the specific step here. Then they will specify the resources required, okay, the time to market. Time to market is the time between the starting of the development of the product and the time specific point when the product reaches the customer. So this development time is time to market. So then also the necessary documents and timing requirements, the coordination requirement, documents which are required, and so forth. So this is developing implementation plans. We will see a case study in the next lecture. In that we will see all these steps, and we will see how do we conduct the value engineering on a specific product, and finally we will have the cost savings. Now next I have here is the implementation phase. The first step here is prepare report. This report has to be a written report. The oral presentation is also helpful, but written report is required for the decision maker to see the facts, the data visualization is used here. He will see the potential savings or maybe profit Then we enhance the probability of approval by involving the change to status quo. Because of this or other pressing priorities, a manager may be slow in making a decision. So, we enhance the probability of approval in some way. So, once the approval is made, we monitor the progress, that when would the implementation, final implementation or final manufacture of the product would start. So, implementation progress must be monitored just as systematically as value engineering study. The value engineering team should ensure that implementation is actually achieved. So, this has to be a sustainable plan. Here sustainable does not mean the environment friendly, sustainable means it should be implementable, it should be realistic. Next is expedite implementation. To minimize delays in the implementation process, the value engineering team should provide assistance, clear up misconceptions and resolve problems that may develop in the implementation process. So, we minimize delays here by clearing misconceptions or solving problems that may arise in the process. This is again a kind of a monitoring here. So, this was our value engineering job plan here. We will see how is this actually carried out in the case study in the next lecture. Next we have the range of application of value engineering. So, value engineering can be applied to almost everything, because every project or process has a function. Anything that has a function, we work on that function. So, value engineering can be applied at any point of the design or process. We will elaborate this thing further, because it is best to apply VE during design or initial phases only. So, value engineering is a problem solving technique. This technique can be used for developing design criteria. So, let me see when to apply value engineering. When should be the value engineering applied? The potential savings for value engineering is maximum if it is applied in the initial phase only. In the planning and analysis phase only, if it is applied, the savings are maximum. In the planning, we review the program, we perform a function analysis of the facility or of the resources which are available, and the maximum cost is there. So, this illustration is for the construction site here. So, if value engineering is applied when the construction is going to be started at this point, even the construction hasn't started, then what would happen? Sometimes value engineering brings a total transformation of the plans. The plans or replanning, redesigning, redocumentation, all those things has to be carried out. And at this point when the construction starts, all the resources are gathered, and therefore, we will have loss here. And if some of the constructions has carried out here, then there will be total loss. We need to demolish the building and rebuild again. Obviously, value engineering would never be applied at do not apply VE. But here we can fudge between these two. Planning and analysis, the systematic design, design development, some savings for value engineering would be there, cost savings would be there. So, at design phase, again I am repeating, the benefits are tremendous. Any changes to the program at this stage have very little, if any, impact on schedule on the total project here. The project would be developed with fewer changes, redesigns and greater understanding by all parties. At planning and analysis, an independent value engineering team can do the job, but at the later stages here, there are other stakeholders, the other contributors who are already working on the project. So the value engineering the team has to have the coordination with these people here. So value engineering should be applied. When should be the value engineering applied? The question is, the answer is apply during planning stage. So I have a task for you people. So today I'll give you a task regarding fast diagram. So the product which you have selected in the previous lecture, you have identified the functions. You have seen what are the primary functions, what is the primary function of the product, what are the primary functions of your components. Then you have also seen the secondary functions. You have seen the functions which are work functions and cell functions. So I would like you to put those functions in a fast diagram, represent those functions in a diagrammatic way. Of the product which you have chosen. Then see what is the scope of your study. This is regarding fast diagram. Second task here is regarding the creativity. So as I told before, if possible, you please group into 3 to 5 persons. Then even if you have different products, one person has chosen product A, second person B, C, D. You should all work together on product A first. Okay, come up with the ideas for product A. How to accomplish function X, how to accomplish function Y, how to accomplish function Z of product A. Please work on this. Create ideas, use some technique like brainstorming. Then you can even checklist various questions. Just enlist the ideas. And in the next talks, when I'll do the case study in the next lecture, then we'll carry these ideas, we'll evaluate these ideas, we'll put the cost to each idea, and then we will evaluate each idea based on the certain measures, certain criteria that we will select. So let us meet in the next lecture where we will see the case study on value engineering. Thank you.